Hey YouTube, in this video I'm going to be sharing with you three properties of logarithms, and these are very, very useful when it comes to rewriting expressions that involve logarithms. But they are the product rule, the quotient rule, and what we call the power rule. And these are the same three rules that you see when we deal with laws of exponents. So let's go ahead and start with the product rule here. It says the properties of exponents correspond to properties of logarithms. For example, when we multiply with the same base, we add exponents. So I guess the idea here is this: when you multiply two things with the same bases, we talk about exponents, we just add the exponents. So the idea here is this: intuitively we could say that the property of exponents, it says here, and coupled with an awareness that a logarithm is an exponent. So here's the deal: logarithms are exponents. So what this does is it suggests that they follow similar properties, product, quotient, and power rule, just like your exponents do. So with our product rule here, when you multiply two things with the same bases, you add the exponents. Let's look at the product rule for logarithms. It says let b be your base. We have m and n be positive real numbers such that our base is not 1. Then we see here that the log base b of m times n, and this is where it gets its name, product rule. I suppose right here. This is the product right here. What we're going to do is we're going to take this log of a product and rewrite it as the sum of the logs. So we say the logarithm of a product is the sum of the logarithms. And you notice here that log base b of m times n, we rewrite this as log base b of m, which was the first factor in our product, plus the log base b of n, which is the second factor in our product. So you notice that we wrote this log of a product as a bunch of individual logs, and they all have the same bases here, base b, but we can say these individual logs, each one containing the individual factors of the product in the first place. So when we use the product rule, let's go ahead and take a look at this here. It says use the product rule to expand each logarithmic expression. So we have log base 6 of 7 times 11. So we immediately spot a product right here. The interesting thing about this is we could rewrite this as log base 6 of the first factor in the product, 7, plus the log base 6 of the second factor in the product. And I don't want to do anything else with this. This is the expanded form. And essentially what you'll see here is this: they both have a base of 6. So it's important that they keep the same base when you rewrite this in expanded form. When we look at this next example here, we want to expand this, we have log of 100x. Now, this is the same thing as log. I'm going to write a few differences here. Log base 10, we must have a common log here, and this is 100 times x. And so in this product, we have two factors, the 100 and the x. So we're going to rewrite this as log of 100 plus the log of x. And the log of 100, by the way, if you wanted to simplify this even further, we could say 10 to the second power equals 100. So this is really 2 plus, oops, I got a little carried away with my 2 there. 2 plus common log of x. But I would say that this is perfectly okay here. So when we look at this product rule, it says the log of a product is the sum of the logs. Then when we look at a quotient rule, this is kind of the exact opposite. When we divide two things with the same bases, we subtract their exponents. We can see this law of exponents right here. Because exponents and logarithms really are the same thing, then let's look at our quotient rule for logarithms. We have let b, m, and n be positive real numbers. And by the way, your base is not equal to 1. And the last property here, we saw the log of a product. Now when we see the log of a quotient, what we get here is this: log base b of m over n is log base b of m, which is the numerator in our quotient here, over log base b of n, which is our denominator in this quotient here. And order certainly does matter, okay? So we say the log of a quotient is the difference of the logs. And so when we look at these two down here, it says use the quotient rule to expand each log expression. We see that in each of these instances, we have a logarithm that we're dealing with and a quotient on the inside of that log. So we'd say log base 8 of 23 xths would be log base 8 of 23, which was the numerator in our quotient, minus log base 8 of x, which was the denominator in our quotient. Likewise here, we have the natural log, and we could see this as being the natural log of the numerator, ln of e to the 5th, plus ln of the denominator, which is this 11 right here. By the way, ln of e to the 5th, this log base e of e to the 5th here, that's the same thing as e. It's like saying e to the what power equals e to the 5th here. We just get 5. Okay, you just get the 5. So we'd say that these kind of undo each other here. I'm going to go ahead and keep this expression and just say we want this in expanded form. But if we simplify this, this would be 5 plus the ln of 11, because ln of e to the power of something undo each other. So now our last property here is our power rule, which says a power to a power is the product of the powers. So basically b to the m to the n is b to the m times n. This property suggests the following properties of logs, called the power rule. Basically, the power rule for logs say that let b, m, no n on this one. Let b and m be positive real numbers and your base is not equal to 1. we say let p be any real number. Essentially, you can see that p here is the exponent. What you see with the power property is that this power gets pulled out front. So we pull the power out front. And by the way, what I mean by pull the power out front, we say that this is the log of something being raised to a power. What I mean is we'll just put that p out front and we'll call this multiplication, okay? So that's our multiplication right there. When we look at these next three examples here, we all have logs of things being raised to a power. So for instance here I have log base 6 of 3 to the 9th. We're just going to pull that 9 out front and we get 9 log base 6 of 3. Likewise here we say ln of the cube root of x. Now the interesting thing here is that we need to rewrite this, and we write this as ln of x to the 1/3 power. Remember that when we write x to the a and bth root here, x to the ath power bth root, that's the same thing as x to the a over b, where we have our power over our root. Okay, so we have a cube root here, so this is the first power third root, but what we can do is we can rewrite this as 1/3 ln of our x there and pull the 1/3 out front. And then last but not least here, people get confused, but we say all of this is being raised to the second, so we'll just pull that 2 out front and we get 2 log base 10 of x plus 4, the common log of x plus 4. In the next video, we'll look at expanding and condensing expressions to as a means to an end when we solve equations. Cheers.